Sometimes ROS packages are not only hosted on the apt source. If you want to use a package that's custom created by some third-party group, you need to actually compile it from their GitHub repository, for example. So Git is a version control software, and GitHub is a website that hosts a bunch of publicly available Git repositories, which are essentially folder structures that you can pull or clone into your local computer. For example, I have created this fork or this modified version of the Baxter simulator from the official Rethink Robotics group. I updated its compatibility so that now it works with the Ubuntu 2004 and ROS Noetic. And I want, since this is a package that is only available with source code, from source code, you cannot install it directly from the apt repository. So what should I do now? The first step is to create a ROS workspace where you want to clone the, because they are packages, like clone, just like the package you created, you need to clone the repository into your local folder inside your workspace and do a cat can make to make it compile along with your other code. Let me demonstrate this here. For example, let me create a, let me open the folder first. Close that. Terminal. So I would like to create a ROS workspace inside the home directory called the simulator workspace. So let me create the folder structure first. So if you do a refresh, this is where my workspace would be resided. CD into it. Make a source folder. After I have made the source folder, I can try to populate the remaining file structure of the ROS workspace. So now you go. This is an empty workspace that I just created. This is the source folder, which has no packages inside it yet. So I now cd into the source folder. So I want to create a workspace containing the Baxter simulator, which is essentially the package contains all these things, which is inside a GitHub repository. So what I would do for a typical GitHub repository like this, you click the code, this green button here, and there is a tab where gives you the HTTPS address you can clone from. I copy that address, and inside the terminal, I type git clone, and then that address, and I hit enter. It will pull the entire remote folder structure inside my local computer. So if I open this folder, see now this content is the same as the one inside my remote repository on GitHub. So now if I get back to my workspace, and do a catkin make, theoretically, it should now see my just created package or packages and build, right? So let's try it. And it says catkin make, it says cmake failed. Let's see what output it pops up. Just trace back, it says cmake error. Could not find a package configuration file provided by Baxter core messages. So that indicates that your package has unmet dependencies. There are a couple of scenarios that could create this. Either, essentially, it suggests that you are missing a package. And that package can be either installed by using apt-get, or it could be ported in, like clone, using git clone and port in from another GitHub repository, which is what we are doing today. Like, we are going to do a git clone of a series of repositories to make you get familiar with how to deal with these things, and also get familiar with how to use the git clone command. So inside the repository, there is actually a ROS install file. And if you go into that file, it gives you a list of repositories that you should be doing git clone and put into your current workspace. That includes the Baxter simulator with this URL and this branch, and Baxter with this URL, Baxter interface, Baxter tools, common, and examples. So we'll clone them one by one. So we'll do a copy. Actually, we can, because we already cloned the first repository, everything is actually inside here. So if you open the same ROS install file here, you'll see what's exactly the same on the remote website. So remember first to go back to the source folder where all the packages are. Git clone. If you want to clone a specific branch, for example, here I tell you, I specify the version, which is the branch name is master. I will add a -b flag, master, and then the and then the URL, just copy over. Destination already. Okay. If you see that, that means it's trying to recreate the folder structure, because the first one, Baxter simulator, is actually the one we just cloned. So let's skip that. Actually, it's pointing to the same URL. Let's do it from the second one. This. Master. So this will create a folder named Baxter. If you go into that, it's essentially an SDK package. And third, that creates the Baxter interface.
And the -b argument is the version?
For the branch or version, yeah. We'll give you a shortcut after this, like to automatically install, automatically execute all these set of commands, but just now we are getting familiar with how to use Git. So Baxter tools. Baxter common, and we have one more. Now we have all the dependencies cloned or pulled from the remote GitHub repositories. We get back to the workspace and do a catkin make from here. Now you should see that it's pulling in, it's seeing all these packages. Okay. Still, you may see some other dependencies missing, which is not provided in the source list. Actually, that means when I created this dependency list, that means these other dependencies can be resolved by installing binaries from the apt repository. So let's do that to fix the remaining dependency misses. We do a sudo apt-get update. Hold on. No pubkey repository, and that is not signed. Okay. Essentially, that means something is messed up here. Let me fix this real quick in a separate window. Let's comment that out for now. Let's try that again. Okay, update is done. So we get back to where this error message is indicating a missing dependency. It says effort controllers config.cmake or is not found, or it says could not find the package configuration file provided by effort_controllers. Okay, so remember that ROS packages actually follow a naming convention. So you can use this error hint and apply it to the naming convention and install the exact package you want. Sudo apt-get install. So the naming convention is ROS dash your ROS version, which is noetic dash the missing package, and replace all underscores with dash. And there you go. Okay, now we have installed one missing dependency. Let's try building it again. Seems fine. Oh, we are building. Okay, So now all the packages are being built. And if you source,
why, before you do that,
okay,
now why replace the dash, the underscore with the dash?
that's just the ROS package naming conventions. Is that the space or the space in between words is underscore in package name, but APT requires it to be a dash. So that's how ROS maintains the package names. It's just do that switching.
Why, what was the, so why was it misnamed with the underscore? We use a bunch of underscores also.
Yes, but that's I guess is the definition. I guess.
Pardon?
I guess that's just the definition. Because yeah, the package names are all separate word separated with underscores, but the APT, I guess it's because APT doesn't like underscores, so they replace it with dashes.
Is that true of all? Because it's got some others.
Yes. Actually, I don't think any APT packages have underscore, now that I recall. All of them are dashes. But yeah, that's been like I never made mistakes with that, and it just works every time. And I believe it's in the documentation somewhere.
So for the case of the, so what we should do is for the case of the simulator, there's just that one package.
Yes, you just need to install that one missing package.
Say, hey, we have to load this with a different name.
Yeah. Okay.
Okay.
Okay. I can modify that and put it in the README of the GitHub page. So now you have all the packages compiled. Yes.
Okay, go ahead.
Okay. We can source the devel slash setup dot bash, and then we can do a ROS pack list, and then see now that all the Baxter related packages are being indexed. So let's play around with the simulator examples here. Yeah, so in the all the packages you have just downloaded in your workspace, there is Baxter Simulator. Under the Baxter Simulator folder, there is a package named Baxter Sim examples, and there is a launch file beneath it that starts up a Baxter doing a pick and place. So we'll try with that. In order to launch it, we go into the workspace we just created. We source the devel setup.bash file here. Double check with the name. So we want to launch a launch file under the Baxter Sim examples package, which is this one, Baxter Sim examples. So we go ahead and do a ROS launch, Baxter Sim examples. And then we don't we can autofill the launch file name or list the launch file if you have multiple by hitting a tab. And it gives me this launch file name, Baxter pick and place demo.launch, which is the one I want. And we'll hit enter. There's something. Okay. Okay, so now the Baxter is started. But why is the pick and place not working? Hold on. Something was complaining. Process has died. Gosh, why? Something is not starting completely. Let's try again. Something is not happy. There we go. Yeah, something is not happy. We'll figure out why, but basically the Baxter robot, the Baxter simulator is started. It's just not doing anything right now. I guess one of the nodes crashed. But we can here we can open new terminal. We can see a bunch of nodes being run and see the Baxter, all the Baxter related. So that's a package has been compiled from source, and now it's being started on the computer. Now there is actually a simpler or a shortcut instruction that utilizes some of the ROS utilities to automatically resolve the dependencies. So remember, we just use the magic file. Where is it? Baxter simulator. The magic file. Baxter _ simulator.ros install. Actually, that's a file I compiled to make one of the ROS install, one of the ROS tools named ROS install to automatically pick it up. So so under the Baxter simulator repository, under the README file, I've actually posted a brief instruction on how you can use the ROS install utility to automatically interpret the ROS install file. So we can try that. To do that, I would create another terminal, and I'll create a clean empty workspace again, and we'll start from there. mkdir. Okay, so this is my my second workspace. We're inside the source folder. What do I say here? So first we need to install. Oh, I guess that's why. I guess it's the ROS controllers and Sacro probably is not installed. Sudo install ROS controller, no edit Sacro. Python 3, ROS install. Python is Python 3. What? No. And then we source the set of the bash of the ROS installation to make ROS install utility being indexed. And double check where we are. Inside the workspace. Okay, so we're inside the source. We need to go one level up and run this line, which essentially tells the ROS install utility to resolve the dependency file that is pulled from this following URL, and this points to a raw page rendering that content of the exact same file. So and resolve the content of it and put it inside the source folder. So let's run that. Essentially, it does all the git clone automatically in one step. Okay. See now you after running that one line command, everything is populated under the source folder.
So you can ignore that raw stack,
Huh?
this error here.
Yes, because I did not yeah, it's like in the very end, so that's safe to ignore. So we can do a cat can make inside the workspace. It should just build as the previous one. Yep. So that's two ways you can install packages from a GitHub repository. Essentially, if the package owner provides you with a ROS install file, you can use the ROS install utility. Otherwise, you have to do a git clone of all the contents of the package and its dependencies. So let's go to this workspace. And source the setup.bash. Also, take note that we are in a different workspace than the previous one. So all the package inside this workspace is isolated from the previous one. So after sourcing the devel setup.bash of this workspace, it only sees the packages residing inside this current workspace and not the previous one. So for example, if you want the code you write to work with like ROS packages pulled from GitHub repository, make sure you're pulling those packages inside your current workspace along like where your code can see, and then you can launch them in one step.
All right.
Sim examples. Yeah, I think that's because of some. There we go. That's because of some of the Sacro files. Sacro, one of the ROS package dependency is not installed. That's why it was not happy. But yeah, now it should. Work. So you can use your mouse to move around. The scrolling is zooming. Right click is also zooming. Left click probably. Left click pans around. Okay. Should we go with a brief introduction to RViz?
Let's do that separately.
Okay. Because I mean, with this running, you can see in RViz a bunch of frames moving around. So I think that would
How
be
did you run?
funny.
Start this program.
Oh, it's just that package, Baxter sim examples. There is a launch file under. So
did when it actually was taking place, you ran the launch file, but
yes,
it just delayed. That was a built-in time delay when it started picking and placing.
Yes, that's a built-in time delay.
I'll just go ahead and show RViz then.
Okay.
And,
well, that thing tumbled around. Okay. Now, okay, so now we have a moving robot. Make sure we are in the same workspace, by the way. CD, CD. Okay. Now we have a moving robot. We can try to visualize it inside RViz, which is a visualization tool that comes with ROS. To run RViz, we can use a command ROS run RViz, the package, and then RViz, the node. And we can hit enter. So this is the RViz interface. By default, you see barely anything. The center is the grid where the world, the rendered world would reside in. Inside the left panel, you see a bunch of display options, including what reference frame to choose, and as well as what topics or what layers, graphical layers to display. Usually, when you come in, you will see this global status error says unknown frame map. And that just means map as a frame name does not exist in the TF, under the TF topic, or no transformation information about map is being published. So we can, to fix that, we can use the drop-down menu, defining the fixed frame, and just pick a frame that is stationary, or you want it to be stationary inside your rendering area. So for example, for this Baxter example, I want world frame to be a stationary frame. So now it says global status OK. That means we are good to proceed. We can add. We can hit the add button here, and you are able to add graphical layers by display name, which essentially is message types. Now you can add all these message types to be rendered inside Arvis, or you can add a specific topic if you want to visualize it. To start with, I want to visualize all the reference frames that the Baxter simulator or the Baxter robot provides. So we'll select by display name, under the drop-down, find the TF, and hit OK. And you can see this this tree structure of all the reference frames that Baxter provides. You can scroll in the visualization plane to panel to zoom in. You can use the right click to zoom in as well, and left click is to move you around. Okay, so this is a bunch of this is a lot of frames, so we want to sparsify it. So we can click the drop down menu, and under the frames, you can see a list of detected frames. And if I uncheck all enable, everything will be gone. And then I can individually pick whatever frame I want to visualize. For example, base. I want the head, which is rotating. And I want is it left wrist or right wrist? It's the left. Okay. So we'll get back to Arvis. So it's the left wrist, which is moving, and left hand, which is under left wrist, and it's fixed with respect to left wrist, and it's moving together. So yeah, so that's how you can visualize transformations in Arvis. And Arvis also provides different visualizations for different message types. For example, if we want to see a bunch of topics, see what is available. Not much. These are just single point range state. For example, for some reason, a package is one of the range sensor to be a laser scan message type. So let's try to visualize that. Is it published? Not quite. I don't think so. Not a very good visualization, I guess. No, it doesn't. We'll have a better. We'll have examples with better visualization effects later on. That no, I don't think this one is
The
showing.
simulator, does it simulate the vision?
Yes, it does actually. We can actually see the camera. So we have a left hand camera, for example, and we can check the image under the image topic. We'll visualize it as an image and hit OK. And you see what the hand camera is seeing out down there. There are a couple of different ways you can visualize an image. For example, if you click on the camera, I bet this is the rendering way. No, it's the same thing. Topic. Yeah, it doesn't have depth for it. This is not an RGBD camera, so it doesn't have depth. But head sonar state point cloud. Yeah, see, this is another example of visualization. I'm visualizing the rangefinder's message, so it sees the hand, and this is visualizing that the distance of an obstacle with the hand. And this is the left side. You see the camera seen from the wrist camera. So yeah, this is what the Baxter simulator can do.